Hello, my friends. This is a lesson that I normally do in class because we cut up paper into a bunch of different tiny pieces. It's very hard to do on Zoom, and so this whole lesson we are skipping. So the lesson for today is actually lesson 2.3. Lesson 2.3, it's got pancakes on the top, and the page number is 93. Page number 93. We're still talking about strategies that we can use to multiply numbers. And last time we talked about prime factorization. And this is another way to break down numbers. So let's read this together. It says a product of identical factors. And remember, a factor is any number that multiplies up to a bigger number, can be written using an exponent and a base. These are new words. The base is the number used as a factor. I'll explain that in a second. The exponent indicates how many times the base is used as that factor. So let's jump in and look at powers and exponents. Example 1. The number of calories in 6 pancakes can be written as 10 to the third power. And that's how you say that little tiny 3. So you say, if I was writing it out, I would say 10 to the third power. You can also say 10 cubed, but right now I just want you to learn 10 to the third power. It says write 10 to the third power, that's 10 with that little 3, as a product of the same factor. Then find the value. So the base of this is the factor. So it's 10 times 10 times 10. You see that the base is the number that they used. So that's our base is 10. It's in red. And the number of times it's multiplied is the exponent. Now please note, and this is really important, this is not 10 times 3. 10 times 3 looks like that. This is 10 times 10 times 10. So it's not 10 times 3. What's 10 times 3? That's 30. Let's check this. What's 10 times 10? 100 times another 10. That's 1,000. 1,000 is way different than 30. So 10 to the third power is 1,000. So 6 pancakes have 1,000 calories, which is 10 to the third power. It says numbers expressed using exponents are called powers. That's why I was saying to the third power. It's like your special skills. Numbers raised to the second or third power have special names. So it wants you to learn that special name. So this one, if we said it, this is how the words would say. So this one right here is 2 to the 5th power. So say that out loud. I know you might be home in a weird place, but say 2 to the 5th power. Now, when it's got a 2 there, it has a special word. So this is 3 to the 2nd power, or you could say 3 squared. So say that out loud, 3 to the 2nd power, or 3 squared. 3 to the 2nd power, or 3 squared. Anytime it's the 2, it can be something squared. And then here's the fancy word for the third power. So this is 10, we say the base number, to the third power, or 10 cubed. So this is 10 to the third power, or 10 cubed. We're going to keep going on the next page. We're going to do some more practice. We got a crazy monkey on this page, you guys. Example 2. Oh, this looks like what we were just doing. Prime factorization. 3 times 3 times 3 times 3. In fact, that was 3 times 3 is 9 times 3 is 27 times 3 is, I don't remember. 27 times 3, I got to do it in my head now. 3 times 3 is 9 times 3 is 27 times 3 is 81. So let's see, what's the base? What's the number that's repeating? The base is 3. The base is 3. Since 3 is used for the factor, how many times? How many times is it used as the factor? Once, twice, 3 times, 4 times. 4 times. So since it's used 4 times, the exponent is 4. So another way you can write this, 3 times 3 times 3 times 3, is 3, a big 3, to the 4th power. And that's an itty bitty 4 on top. 3 is my base number, that's the factor, and the number of times it's used is the top number, the exponent. So now look at this prime factorization. So it says complete this factor tree. So this is what we were doing the other day. So we started with 72 and we had 2 branches on our tree. And it did 9 times something is 72. So if you don't remember, we go to 9 times what gives us 72? 8. So we're going to fill out this factor tree. 9 times 8 is 72. Well, okay, now let's take care of this 9. 9 is what times what? 3 times 3. And remember, I like to circle them and say we're done. The book has you rewrite them on the tree. I like to have you circle them when we're done. When they're prime, I like to have you circle. Now let's head over to this number. It's not circled, and this is why I like the circle method, because you have to end with circled numbers at this point. What times what is 8? 2 times 4 is 8. And that's right, 2, remember, is a prime number, and we don't need that bottom box. 4, still not circled, so we still have a number down at the bottom that's not circled. It hasn't been factored yet, and that's 2 times 2. So my entire bottom row is circled, so I know that I've got it right. So now remember, we put them in order from least to greatest. So here we go, 2 times 2 times 2 times 3 times 3. Now, that's a little bit crazy, 2 times 2 times 2 times 3 times 3, right? So instead of doing that, we can write it with powers and exponents. So it's got 2 to the what power? How many times did we use 2? 1, 2, 3. So we're going to put an itty bitty 3. 2 to the 3rd power times, how many times did we use the number 3? 1, 2, 2. So this is 3 to the 2nd power, and that's that itty bitty 2 on top of the 3. And remember, we can also say this is 2 cubed or 3 squared if we wanted to. So 72 is 2 to the 3rd power times 3 squared. What's that?
Amelia, come watch school.
In the back.
Will you just help me switch it to HDMI3?
Dad's back there, I think.
He is?
Yeah, he just came in.
No, he didn't. I saw him walk down. He went to Jensen's.
Oh, you're right. Can you ask Abby to help you? Because I'm trying to film this lesson. And have them come in quietly. So that 72 is 2 to the 3rd power times 3 to the 2nd power, or 2 cubed times 3 squared. Okay, let's do our guided practice together. It says write 4 times 4 times 4 times 4 using an exponent. Well, my base is what? What's the factor that we've pulled out? A 4. Since 4 is used as a factor, how many times? 1, 2, 3, 4 times, also 4. The exponent is also 4. So 4 times 4 times 4 times 4 is a big 4. Oh, you can't see, sorry. Is a 4 times 4 times 4 times 4 is a big 4. That's my base. It's the factor. And I used it 1, 2, 3, 4 times. So I put a little bitty 4. 4 to the 4th power. 4 to the 4th power. Feel free to pause here if you need more time to work on this page or to fill this out. If not, we're going to move on to the next page. Okay, independent practice. We've got to write each product which is a multiplication problem, the answer to a multiplication problem using an exponent. And remember, exponents are the little numbers on top, okay? So 10 times 10. What's the factor, the base that's repeating? Yep, it's a 10. How many times did it repeat? 1, 2. So it's 10 squared. And remember, that's not 10 times 2. 10 times 2 is 20. This is 10 times 10. What's 10 times 10? 100. So that little baby 2 doesn't mean multiply. It means the powers of it. We're going that number times itself over and over again. Let's take a look at number 3. 8 times 8 times 8 times 8. What's my base? What's the factor that's repeating? Yes, it's an 8. How many times did it repeat? 1, 2, 3, 4. 4 times. So we put my itty bitty 4 and we say 8 to the 4th power. I would like you guys to pause here and I want you to try to do number 4, 5, 6, and 7 on your own. Pause here, do 4, 5, 6, and 7 on your own, and then come back and check your work. Okay, you guys, we're going to check our work here on these ones that you did on your own. I still wanted you to do that, but I circled it funny. So we're going to rewrite this using an exponent. So we've got 3 times 3 times 3 times 3 times 3 times 3. That's hard to say. So we're going to instead make our base, which is the factor that keeps repeating. I have a 3, 3, 3, so my base is a 3. How many times did it multiply? 1, 2, 3, 4, 5, 6. 3 to the 6th power is the same thing as 3 times 3 times 3 times 3 times 3 times 3. It's just a lot easier to say. Let's look at number 5. Check your work here. My base is a 5, and I check 1, 2, 3, 4, 5. Oh, another 5, but this one's got to be little. Now watch, I have students do this all the time. They go like this, and they tell me one of those is little, and one of those is big. No, that looks like a 55 to me. You got to make sure one is nice and big, and one is nice and small. If you don't do that, it's easy to get those marked wrong or to get confused with your math. Let's do number 6. We've got 9 times 9 times 9 times 9. The factor that's repeating is 9. It's my base. The number of times it repeated, 1, 2, 3, 4, 4. So my answer is 9 to the 4th power. And the last one is 1 times 1 times 1 times 1 times 1 to the 5th power. Oops, I feel like that 5 is a little too big. Now there's something really funny about this one, you guys. What's 1 times 1? 1 times 1, 1 times 1, 1 times 1, 1. So all of that is still just 1. Okay, let's take a look at number 8. This time we're doing the opposite. It's giving us the base and the exponent, and it wants us to write it out as the factors. And then we have to find the value. 2 things. So we've got 10 to the 4th power. That is, here's my base. That's going to repeat. 10 times 10. That's 2 times. How many times do I have to go? 4. Times 10. 1, 2, 3. One more. Times 10. 10 times 10 times 10 times 10. 10 to the 4th power. And we have to solve this. 10 times 10 is 100. Times another 10 is 1,000. Times another 10 is 10,000. Whoa, that number got big fast. 10 times 10 times 10 times 10 is 10,000. Okay, let's look at number 9. We've got 3 squared, or 3 to the 2nd power. That's 3 times 3. That's 3 is my base, and I repeat it 2 times. So what's 3 times 3? Oh, easy peasy. That one's 9. That was a lot easier than that big one above it, wasn't it? Let's do this one together as well. We've got 9 times 9 times 9. Do I stop? Yes, I've got 3 times 9 repeats. There's three factors of 9. And then I have to solve. What's 9 times 9? Oh, I know that one. That's 81. But what's 81 times 9? I'm going to need the side of my paper. Remember, when I'm doing multiplication, I write it out with the 2 numbers on top of each other, and then I start in the ones and I multiply. So 9 times 1 is 9. Then I'm done with that. 9 times 8. 9 times 8, if everybody remembers, is 72. So my answer here, 9 cubed, or 9 to the 3rd power, is 729. That's a big number too. Let's try doing number 11 on your own. Pause the video here and then come back and check your work. Okay, so for number 11, we did the base is 6. So that's my factor that repeats. 6 times 6 times 6, that's 1, 2, 3. I need 5 of them. Times 6 times 6. 6, 1, 2, 3, 4, 5. I checked, I've got 5 of them. Now I have to do the multiplying. And sometimes, you guys, this gets a little bit crazy, this multiplication. And so for the sake of time, we're going to check our work here. And I'm going to use the calculator to show you how this works. So 6 times 6 times 6 times 6 times 6. 1, 2, 3, 4, 5, 6 is 7,776. 7,776. That's a huge number for just this thing that says 6 to the 5th power. But we know that if we did 6 times 6, it'd be 36. Now we do 36 times 6. Oh, we're getting big. And that's how we get all the way up to that number. If you didn't get this number, that's okay. Right now I want you to focus on this, getting the 5 different groups of 6s there. 6 times 6 times 6 times 6 times 6. Okay, let's do question 12. Oops, sorry about that. Question 12 says, write the prime factorization of each number using exponents. So it's given me a number, you guys. I've got to make a factor tree. So 25, it has branches on its tree. We did this last time. What times what is 25? If you don't remember, this is why our math facts are so important, you guys. 5 times 5 is 25. 5 times 5 is 25. And I remember that I can't break this down anymore. What times what is 5? Well, here's a 5. Oh, but it's just 1 and 5. It's 1 in itself. Let's see, any other 5s? Oh, there's a 5. Oh, but it's just 1 in itself. That's it, you guys, because remember, 5s are our special numbers we call prime numbers. And remember, here's our list. 3, excuse me. 2, oh, I know why I messed up. Okay, here we go. 2, 3, 5, 7, 11, 13. Everybody say that for me one time. 2, 3, 5, 7, 11, 13. 2, 3, 5, 7, 11, 13. Still coming in handy for me. So I've got 2 groups of 5 here. So what's my factor that's repeating? 5. My big number, my base is 5. And how many times did it repeat? Just 2. 2 times. So that's 5 squared, or 5 to the 2nd power. Let's do 56. 56. Make my factor tree. I look on my chart here and I go 56, 56. Oh, here it is. 7 times 8. 7 times 8. Okay, so let's do 7 times 8. Well, I remember 7 is part of my prime numbers, so I'm going to circle it. But 8 isn't, so I have to keep going. What times what is 8? Well, 2 times 4, right? 2 is a prime number, so I can circle that. But 4, I can break that guy down more into chunks. So 4 is 2 times 2. So remember on our previous lesson, we wrote 2 times 2 times 2 times 7. So we wrote it like this, 2 times 2 times 2 times 7, from smallest to largest. Now we're just going to group these together. 2 is my base. How many times did 2 repeat? 3 times. So 2 to the third power, or 2 cubed, times 7. 2 to the third power times 7. 2 more, you guys, 2 more, and then we're going to take a break and we're actually going to be done. We're not going to do the back. 2 more, hang with me. 68. Let's do our factor tree for 68. 68 is our factor tree. Now, the bummer about the number 68 is it's kind of bigger than a lot of the ones you'll see on here, and you're not going to find a 68 on here. Now, it's an even number, so I know that a 2 can be divided out. Anytime a number is even, a 2 can be taken out, and 2 is prime. So I've got a 2 out, but now I've got to divide it. So I've got 2 goes into 68, 2 goes into 6 3 times. 3 times 2 is 6. Bring down. 2 goes into 8 4 times. 8, bring down. Okay, 34. Whew. That's big, 34. But that's another even one, so I know a 2 can come out. And there's another prime. 2 times what gives me 34? Well, you know what? I don't know. We got to divide that out again. So I take my 34, put it inside the house. 2 goes into 3 one time. 1 times 2 is 2. Subtract. Bring down. 2 goes into 14 7 times. So it's 2 times 17. Oh, wasn't supposed to circle that. 2 times 17. But I will tell you that 17, it's not even. A 2 can't go out. Can a 3 come out of it 17 even? 3 times something get you 17? No. 3 times 5 is 15. 3 times 6 is 18. No. What about 4? 4 times 3 is 12. 4 times 4, 16. Oh, not close. 4 times 5, 20. No. What about 5? No. 5 times 3, 5. No, that ends in zeros and 5s. 6 times 2 is 12. No. 6 times 3 is 18. No, too high. What about 7? No. 7 times 2 is 14. 7 times 3 is 21. What about 8? 8 times 2 is 16. Oh, so close. What about 9? 9 times 2 is 18. Nope. What about 10? Definitely not, right? 10 times 1 is 10. 10 times 2 is 20. What about 11? No, it's too big. This is why knowing these facts and knowing that you will not find a 17 on here is helpful, so that you can know that 17 is, in fact, a prime number. I didn't mean to circle this earlier, you guys. That's not a prime number. I apologize. Your teacher made a mistake, and I ask you to forgive me. So we have 2 times 2 times 17. Now remember, previously we would have wrote 2 times 2 times 17, but it wants us to use exponents. So we've got, this is the one that's repeating, so it's my base. How many times did it repeat? 1, 2. 2 squared, or 2 to the second power, times 17. Holy cramoles, you guys. One more factorization. We do the factor tree. We write our 88 at the top. We give it branches. What times what is 88? Well, if you don't remember, look at your chart. Oh, here's an 88. It's 11 times 8. So let's do 8 times 11. Wait a minute. 11 is important. 2, 3, 5, 7, 11, 13. It's a prime number. That dude's already done. Awesome. Okay, what about 8? No. Let's divide it up into chunks. 8 is 2 times 4. Yep, and 2 I know is prime. What about 4? Is 4 prime? No, I can take out 2's. 2 times 2 is 4. So we would have written 2 times 2 times 2 times 11. But because of the exponents, we're going to write 2 to the 1, 2, 3 third power times 11. Fantastic work, you guys. You do not have to do this page. You do not have to do this page. And you guys are doing great. Put a smile on your face. Remember, you can't do it yet. If you're getting stuck, if you're getting frustrated, remember this mindset. I can't do it yet, because you will get this. Keep it up.